Good friends, welcome back. So we're gonna continue from where we stopped the last time. Remember that we treated this. That is still dealing with what we have as an operation with logarithms, which are negative. The last class we were still dealing with it. We took about 2 classes to handle that. And then we said when it's to come back, we focus on powers and roots of numbers less than 1. Now there's something you need to note, that the rules are exactly the same as the rules for numbers greater than 1. Let me just write it down. Notes. The rules are exactly the same as the rules for numbers greater than 1. Now let's see examples. Let's take some examples. Evaluate a 0.0587 to the power of 4 and B. We have the cube roots of 0.00894. Now give the answers to 2 significant figures. Give the answers to 2 significant figures. So let's solve this. We can use standard form method to solve this problem. On the other hand, it is easier and faster if we use the tabular method. And I like using the tabular method, but both methods, I taught you both methods. Previous videos you'll see the other method. So let me go straight using the tabular method, right? It's obviously easier and faster, or at least faster. And it's very simple too. So we have 0.0587 to raised to the power of 4. Alright, I will create a table. Let's generate the table. We have the number, the log. The number here is 0.05872. The logarithm of this is obviously going to be, it is about 2.7687. We have 0.0587 to the power of 4. Why is it raised to the power of 4? We have done this, but this is raised to the power of 4, and this is what we're actually after. What we just did here is just an attempt to simplify this first. Now, since it is raised to the power of 4, it means we're going to multiply its logarithm by 4. So this is equivalent to this. That is its logarithm. Now its logarithm should be this. Multiply the logarithm by 4. Remember the rule for dealing with powers. If it is power, you multiply the logarithm by the power. Now, This is giving us by 5.0748. You need to know how to do this. You don't know it, go to previous videos. There are videos where we treated this. We will not go to all of that to save our time. 0.00001186. And you see by 5. How many zeros are here? 5 zeros. Reflecting the characteristic that we have, which is by 5. How do we get these figures? You know, when you are looking for searching the answer logs, that is to say that 0.000012 to 2 significant figures is what the answer is going to finally be. If you approximate this to 2 significant figures, 1, 2. Right. If you have to rough check, you see that 0.06 approximated is a power of 4 is equal to 0.00001296. See that? So that's that. It's as simple as that. Let's take the next one. Okay. You have the cube roots of 0.00894, and then I hope you know this is the same as 0.00894 raised to the power of 1/3. Yes, in maths, if you have fourth root, is fourth root of a is the same thing as a raised to the power of half. A raised to the power of 1/4, I mean to say. Then if you have seventh root of let's say b, it simply means b raised to the power of 1/7. If you have ninth root of 16, it simply means c raised to the power of 1/9. So that's the logic used here. It's one of the laws of indices that we are applying now. Now, let's generate out the table. That number log. Here we have 0.00894, which is this number here. The logarithm is about 3.9513. Can't verify. So that means its cube root is going to be what? Guess you have the right guess. Yeah, to divide. So you divide the obtained logarithm by the cube root, which is 3. And your answer is going to be about 1.3171. And its antilog is going to be 0.2075. And that is to say that 0.21 to 2 significant figures is what we obtain. Right? If you are to check roughly, you see that the cube root of 0.008, just try to press the calculator, is similar to, you're going to get something like this, 0.2. So, further examples, let's take more examples. Further examples. So work out the following giving the answers in bar notation. If you then give the answers in bar notation, 1 you have bar 2.98 times 3. You have about 3.7 divided by 4. We also have about 4.235 divided by 3. Now if I have to solve this now, if you have about 2.98, you have to multiply it by 3 as we have here. How is it going to be? This is what you simply do. It's like saying you have bar 2 plus 0.98. Then you want to multiply this by 3. I hope you know. You must know that if you have 1.5, that's the same thing as 1 plus 0.5. That's the logic we're using here now. You have about 2 plus 0.98, similar to this. Then you multiply by 3. So you just break it down the expression. What do we have? You can multiply. 3 times 8 is 24. Put down 4, carry 2. 3 times 9 is 27. Plus 2, 9, 29. Put down 9, carry 2. Right? 3 times 0 is 0. Plus the 2. You have 2 points here. Now, we have this. 3 times bar 2 is what? Bar 6. Let me put this here first. We have bar 6. Good. So the results is simply bar 6 plus 2 is we are simplifying the characteristics separately. Characteristics refer to the part that is on the left hand side of the decimal point, and the other side is the mantissa. That's on the right hand side. So what are we going to get? This simply means that our answer is bar 6 plus 2 is what? Bar 4. So answer is bar 4.94. This becomes our answer. I hope that is simple and very clear. Let's see the next one. The next one we have about 3.7 divided by 4. And this is similar to bar 3 plus 0.7. Now, if we have bar 3 plus 0.7, you agree with me that we can express it like this. We can also express it like this. Bar 4 plus 1.7, because bar 4 plus 1 will still give us the bar 3. Now, you know how to do this. We have done this before when we were dealing with operations, operations or logarithms that have negative values. So we've done all of this. So you now know why we are expressing this in form of bar 4 plus 1. I mean, you see that it is possible. And you should agree with it if you have watched those videos and understood them clearly. Now, why do I choose to express it like this? We are dividing by 4. Since we are dividing by 4, I want to make the characteristic divisible by 4. You get the logic now? Good. So let's say if 4 is to divide, these are characteristic that we have here. It's going to be by 1. So the logic, right? So that is what we are doing here. Now we have plus 0.425. Can do the work. Try to divide this by 4. See what I got here when I divided it. 6.2. You have Bar 4 divided by 4. Similar to saying minus 4 divided by 4. You have minus 1, right? So I got bar 1. Now we have what we have left is bar as a 1.7. Let's see. I have 1.7 divided by 4. So 15 over 40. This is similar to 0.425. So that is what I got here. And that means this is equal to this plus this is bar 1 is 425. Bar 1 plus 0 is bar 1, then 0.425. Now, let's take the last, and then we'll go for our exercises. We have bar 4.2351 divided by 3. This is this is the same thing as we can express it like this: bar 4 plus 2.2351. And then since we want to make the expression divisible by 3, we can increase it from bar 4 to bar 6. So let's say bar 6. But if it is bar 6, we need to add 2, because bar 6 plus 2 will take us back to the bar 4. So that we can balance, we can cancel the adjustment we just did. Otherwise, we'll alter the expression. We need to balance the characteristic. That is why, since we alter the characteristic by making it bar 6, just to make it divisible by 3, we need to add a value that will make it still equal to the original characteristic that we have. Now we have bar 6 plus 2.2351. Now we can go ahead and divide. If 3 divide bar 6, take note that the number dividing divides the characteristic separately from the mantissa. Now you can see I'm dividing the characteristic first. If 3 divided by 6, this is, let me express it in another form. This is like saying all over 3. You get that? Which we now try to make it like this: bar 6 plus 2.2351. This one divided by 3. And this one also divided by 3. That's the logic we are using here now. Now, if 3 divided by 6, we are going to get bar 2, right? So we have bar 2 here. See that? Now, 3 divide 2.2351. What am I going to get? 2.2351. What's your calculator? Divided by 3. You get 0.7450. You can see that 333. So let me see. I got 0.7450. And that means our answer is bar 2. Bar 2 plus 0 is bar 2.7450. That's our answer. Finally. So let's take these exercises. Exercise. Work at the following giving the answers in bar notation. One, we have 2.4 times 3. So we have 4.16 divided by 4. Then we have about 6.4 divided by 5. Okay, let me take a figure that is maybe it's we have 4.3217 divided by 3. So let me just make them 4 in number. Number 4 we have 6.905 divided by 5. So what are the answers? I have answer from 1, 2, 3, 4, and 5. For 1, which is about 2.4 times 3. Our answer should be about 5.2. About 5.2. And then for number 2, which is about 4.16 divided by 4, our answer is about 1.4. For number 3, which is about 6.4, about 6.4 divided by 5. Our answer is about 2.88. About 2.88. Number 4. Number 4 question is about 4.3217 by 3. Our answer is about 2.7739 as presented in this textbook. Then 5. 1, 2, 3, 4, 5. This should be number 5. And we have 6.905 divided by 5. Our answer is about 2.981. So you attempt to solve them. After solving, you compare your answers with what you got here to help yourself. Now, we will forge ahead a bit. We are going to evaluate numbers. So 3 significant figures, and we use rough calculations to check the answers. You understand? See further examples. Question 6, evaluate if we go into 3 significant figures and use rough calculation to check the answers. So let's see. First one I have here is 0.0928 cube. Then the second one is And let's see. I've prepared my table for this, the first one. So I shouldn't be speaking much now. By now you should be familiar with how this is done. Just find a logarithm, which should be this in this case. Since it is cube, we multiply by 3. Then as for what you are going to get is, if you multiply this, you get by 4.9025. Take the anti-log, it's going to give you 2.007989. And that is to say that you have 0.000799 to 30 can't figures. If you have to check, this is approximately 0.09 cube, right? If you have to check, this is equivalent to 0.000729. You see how close to this the answer is. Now, let me check on that one I have here. As B, this particular one, we are going to attempt it now. The B parts, if we are to generate our table, what we have here is the fourth root of 0.08945. The logarithm is about 3.9515 divided by 4. If we divide the logarithm by 4, since we have the fourth root here, our answer is going to be 1.4879. Verify. You can try to verify. And then anti-log is 0.3075. And that implies that we have 0.308 approximately. So 3 significant figures. Now if you are to check, you see that this is approximately 0.3. If you take this now 0.3 raised to the power of 4. What do we have? So what we have here, 8.1 blah blah times 10 to the power of minus 3, which is similar to 0.0081. Right. This is just like saying 10 to the power minus 3, that is 0.0081. You know how to express this in this form. There are 3 zeros here. When you see 10 to the power minus 3, there are 3 zeros before this 81. This one is the standard notation. Remember. So this is that. Now, let's take another example. Another example. Let me call this example C. One more example. Let me call it one more example. This is example C. Evaluate the fourth root 0.3598 divided by 86.59, comma, giving the answer to three significant figures. So we have solution, generate our table. Number log, I have 0.3598. The logarithm is by 1.5561. She check 86.59. We have 1.9375. Now we are subtracting because this is division. Right now we subtract, we have 3.6186. That's for this expression. Now this is that. Now that we have done this, we are going to proceed to the more complex part of it. It's still simple. The sixth root, sorry, what I have here is sixth roots. The sixth root of what we have here, which is 0.3598 divided by 86.59, simply means, since the whole of this, the logarithm is this, simply means you have about 3.6186, right? Divided by 6. You know, it's the sixth root. Remember the rule. And that means we are going to have, if you divide this, we have by 1.6031, and the answer of is 0.4010, and that is 0.401. Correct, so three significant figures, right? I guess you know what we did here in this case. How did we do it? This particular place, what kind of manipulation did we do? Yeah, if we try to make it by 6 so that it can be divisible by 6, then we balance it by adding 3 so that the characteristics will not be altered. By 6 plus 3 will still give us by 3. You see it? Then our matrix remains there the same. So if we divide both by 6, let me say this divided by 6. 6 divided this, we have by 1, right? Then 6 divided this, you press the calculator, you have 3.6186 divided by 3. 6, 9. It's going to give us this. 0.6031, right? 0.6031 plus this, it's going to give us this. Hence, we got by 1.6031. That's how we got what we have here. So we'll take down these exercises. We have more exercises. Exercise. It evaluates the following to three significant figures and check the answers. First, I have 0.897 with power of 3. have 98.13. Make this a decimal point. 98.13 divided by 679.2 is power 4. 3. We have the square root of 3.98 divided by 890.5, and then we have 78.9 all over 590 is power 1 over 3. Let's stop here. Let me give you one more. We have equal to 0.078 divided by 0.652 times 0.841. So what are our corresponding answers? Go to the book. What I have here is 1.8. So let me get the answers for you. While you solve, you compare what you are obtaining with what we have here. The one which is 0.897 cubed. The answer should be 0.722. Number two is 98.13. 98.13 divided by 679.2 is the power of 4. And that is answer is 0.000436. Then the next square root of 3.98 over 890.5. The answer is 0.0669. Then finally, we'll have the fourth one. Let's say the fourth. Number 4. We have 78.94 over 3 over 519. Our answer is 0.511. 0.511. For number 5. Number 5, which is the fourth total of this. Our answer is 0.614. 0.614. Right. Good. So that is what we expect that we should do today, or at least in this video. Now we'll deal with further calculations using logarithms when next we meet. Remember, we are dealing with powers and roots of numbers less than 1. That's what we focused on in this video. So when next to come, we are going to address some further calculations. Let me say further calculations using logarithms. So we'll explore more calculations using logarithms. After this, go to simple logarithmic equations, and call it a day. Thank you for watching. Or we can just finish this in this class so that when next will come, we'll go for simple logarithmic equations, since these calculations are similar to the ones we have done in this class. Let's just combine it with what we have in this class. So let's take this example. What I have here is evaluate 4.536 times x power minus 5 is power 4 all over cube root of 7.536 times x power minus 4. So solution, let's solve this. Let's generate our table. We have number and logarithm. We have 4.536 times x power minus 5. The answer is 5.6567. Yeah. Then since it is 0 to the power of 4, we say 0 to the power of 4, we will say times 4. The logarithm of this is this, and that is equal to 18.6268. Confirm with your calculator. So this is for the numerator. Now we have 4.536 times x power minus 5. Then raise to the power of 4 again. We still raise to the power of 4. Just as it is expressed here. Now we have the cube roots of 0.536 times x power minus 4. This is simply bar 4. This one is bar 5 because I didn't put the bar. Then cubes of this x power minus 4. This is bar 4. X power minus 4. This is obviously the characteristic is bar 4. That's why you see 10 power minus 4. It's just like saying 0.000, that is 4 zeros before writing 7536. Here we have bar 4.8771 divided by 3. You know what to do? Just how do we simplify this? Increase it over 6 or reduce it over 6 and then add 2. Right? So balance the characteristic. If you divide by both sides by 3, it's going to give you, for this you have bar 2, and then for this you have 0.9590, right? So what do we have here finally? Simply means we have bar divided by what? Okay, bar 2, right? You have bar 2. So this is equal to bar 2.9590. Now, if we are to find the antilog, our antilog is 4.653 times x power minus 17. press the calculator, it will give you that. If you say we should write 0.00000 in 70 places, instead of that, you can just condense it, write it in form of the standard form, and that is 4.653 times 10 to the power of minus 17. Even if you have to express it in this form, you see when you can't figures. Now, since the question is given in standard form, the answer should be in standard form. Just take note of that. It becomes our answer. We have another one here. I'll leave this one to you. Maybe. Okay, well, let me just give it to you. Since we have only 2 examples under this, let me call this one example 1. And example 2 says evaluate 0.0968 square times 0.07573 is power minus 15. Solution. And 0.0968 square times 0.07573 raised to the power of minus 3/2 is the same thing as 0.0968 square divided by 0.07573 is the power of 3/2. Now, you may ask, why is it like that? Well, that is a rule in mathematics, one of the laws of indices. If you have let's say, s to the power of minus a, it is the same thing as 1/x raised to the power. If you have y raised to the power of minus b, it's the same thing as 1/y raised to the power of b. So that is the rule that is applied here. When you have this is power of minus 3/2, it means you have this times 1/this. This can be rewritten in this form. Considering what I just explained here, it means we can write this in this form. 0.0968 square times 1/0.07573 raised to the power of 3/2. You see that? And if you simplify this, let's make this 1/1 so that they will look alike. Fractions. This times this is equal to what we have here. Of course, anything times 1 is itself. Now, this times this will give you this. So, this is exactly what was done. That is how we arrived here. Now, let's generate our numbers in the log table. I have our numbers here. As for this first number, 0.0968 square, what we have is about 2.9859 times 2, and that means its log is about 3.9718. You understand that, right? I mean, take the logarithm of this you get this, then multiply by 2. Since it's just the power of 2, you get this as a final answer. And if you go for this, 0.07573 raised to the power of 3, you will actually get about 2.8793 times 3, and your answer is going to be equal to this. This will be equal to about 4.6. Let me say this is about 4.6379. And if you have 0.07573, it's about 3/2. This is let me separate this, but let me just leave it. This is about 4.6379 divided by 2. You get the logic, right? How is that done? This is what is done. First of all, we have gotten this. We are done with that. Now here, since this is the power of 3, we multiply its logarithm by 3, and we got this. Now, since we have gotten this, it means when we are now dividing the power by 2, it means the result we have got to now, we are dividing it by 2. That is what you do. This raised to this power gave us this. But what we have here is this raised to this power over another number here. This is the power 3/2. So what you do is, after getting this, you divide by these 2. You understand that? So we divide by 2. And what we get is about 2.3190. So meaning we have about 2.3190 for the whole of this expression, right? Which is the entire denominator of the expression. So for numerator, this is what we have. And then for the denominator, this is what we have. Now what are we to do? Are we to add or subtract? Obviously we are subtracting. Why are we subtracting? This divided by this means this minus this, the logarithm. Now let's subtract the logarithm there. If you do the subtraction, you are going to have about 1.6528. You have about 1.6528. Take your antilog. You get 0.4495, and that is equivalent to 0.450 to 3 significant figures. So it is as simple as that. We have another example. This one is a past WAEC question. It says I call this example 1 and 2, right? Let me call this example 3. This one is past WAEC question. So use logarithm to evaluate to 3 significant figures. A 50.05 times the square root of 0.00695 over 6.95 times 10 square. Then B, we have another Y question here. 566 times 0.3892 all over 467.1 all squared. So let's solve the first one. Generate our table. I have number log. We have 50.05. That's the first number here. Its logarithm is 1.1775. And the square root of this 0.00695. Here we're going to have 3.8420 divided by 2. You know why we are divided by 2? Let me bring this out. Now this is the same thing as about 4 plus 1.8420. About 4 plus 1 is by 3. Just in a bit to make it divisible by 2. And we end up having about 2.921. What I'm doing here is just a rough work to explain what we are going to get here. So, meaning that finally we get 1.1775 here, and for this we got about 2.921. We're going to subtract or add up. Let's see. This is multiplying this, so we add up the logarithms. What do we have here? Yeah, we have 0.0985. So let's see, we have 0.0985 here now. Let me bring it here. Now 0.0985. This is how this is clear to you. Now, this is for this. Again, you know that we have this. Let's go for the denominator. We have 6.95 times 10 squared, which is 2.8420 if you take the logarithm. So that means we are going to subtract 2420 from what we got earlier, because we are dividing this by this. So we subtract the logarithm of this from the logarithm of this total result. So what we got here for this denominator now, the logarithm, we are subtracting it from this logarithm of the numerator. You know, the whole of this, we are working to get the logarithm of the numerator. Now, if we are to simplify this, what do we have? Simplify this, we are going to get about 3 points. 2565. You can settle down and do your work by yourself to verify. So we have about 3 points. 2465. You now take the antilog. You take the antilog of this. You will get 0.001805. And that implies that 0.00181 to 3 significant figures. Now, let me leave the next one to you as assignment. And this one as assignment. Let me convert it into assignment. But your answer is going to be 0.606 to 3 significant figures. So now next class we'll be dealing with simple logarithmic equations. Simple logarithmic equations. That's what we'll be dealing with in our last class. And after dealing with simple logarithmic equations, it means we are through with this topic, logarithm. We'll go for the next topic, which is approximation and accuracy. Thank you for watching. I am Lucky Wajirogane Jumbo. You can continue watching via this channel to promote the channel. We attract more subscribers and it will be helpful for me. Else, it motivates me to grow my channel. I would appreciate that very much. As well, I impart knowledge on those who are interested in learning. They will get knowledge. Mathematics is actually simple and interesting. Just to get a good foundation, have it well explained to you, or just get the concepts. Simple as that. Have a blessed day. Goodbye. Till we meet for the next video.